Welcome back to part 5 of the Satisfactory tutorial. In this part we're going to be going over crafting and creating constructors or smelters or other crafting buildings like you see in the game. Although for this part we're going to be focusing on just one input and one output, just to keep it simple for now, and maybe later down the line we'll start increasing those and have different types like liquids, etc. So before we actually get into working on the constructors, we actually have quite a decent bit of bug fixing to do before we even get there, because some people made me notice in the last part, bug that exists, is that we can actually create a loop here if we go around and bring this back. If we delete this here and connect it back here, if it allows us to, because it's a bit laggy, we end up with a few issues. So the ones that already should be deleted, but we get a bit of a situation like this, which is not normal, and it kind of blocks there, which is not correct. So we're going to be fixing that first, and then we'll look into making the crafter. So we have a lot of issues here as well, obviously. So to get started, we're going to go into the A item, and we're going to make some small changes in there first. So the first thing we're going to go and change is the condition to stop. Currently it looks like this, and we're going to change it to make it a bit more organized, easier to read, and make a few changes so that it is more smooth. And the main change is we're going to use this, obviously. Let's go and set that up. So the first thing we want to do is we're going to change this into having different branches, etc., so it's easier to read, and we can have separate values that are easier to confirm initially before just doing one large thing here. So we'll put a first branch, and our first branch is going to be called based on this. That way we can have, if we're on the same conveyor or if we're on the next one, we'll know. If we're on the same two items or on the same conveyor, or if they're not. The next thing we want, so we'll start with the actual true. So if we're on the same conveyor, we'll want to get our value here. Copy this. Now, before we go any further, we need to actually set something up for the next part that we'll be doing after, which is if we have a loop, we need to be able to tell the last item that, we need to tell the first item that is moving that it needs to, if it ever catches up to the last item, it needs to stop. Because currently it doesn't know that because it's the first item. So to set that up, we need to also take into account that the item will be behind, because it will be next item, but it will be behind it. So to let it know that, we need to make sure that if the value is 0 or inferior to 0, which we'll be setting up here instead of this, then we can tell it to straight away ignore and say we keep moving. So we're going to actually promote this to a variable because it will be easier to use that way. That way we don't have to keep calling it. So promote it to L distance. Plug that into true. Drag it here, and we'll just copy this for now and get rid of it. What we'll do on branch, we'll add a branch here. And if distance is superior, that's right. If it's superior to 0, that means we're in a normal situation. So we'll do the complete calculation where we check if it's inferior to item interval. Otherwise, we're just going to return that we don't want to stop it, that we can just keep going. So to do that, we're going to get our L distance here. And with L distance, we will check if it is inferior to the item interval. But we also need to check whether the item is stopped. So we can just copy that from here. Get is stopped for the item in front, and put this in the return value. This is going to go to the branch, obviously. Once it's all attached, there we go. We can move on to the second part here. Make sure you keep most of this because we will still need, so we don't need this anymore, but we're going to be needing this part for the bottom here. So for the bottom, one thing we actually need to do first is we need to get a conveyor reference, because in some cases, even if we're not on the same conveyor, we may be multiple conveyor, the two items may be multiple conveyors apart. So if that's the case, we're just going to automatically assume that, well, we can keep going, because with that far apart, it doesn't matter. So to check that, we need to get our conveyor reference and search for get next build. And with get next build, we'll connect it to false. And what we're going to check is whether the out build is double equal to our item in front conveyor ref. And if it is, then that means it's in the conveyor in front, so we can use our formula here. But if it isn't, then that means we can automatically assume that we are further away than the other one, and so we can just ignore the conditions and just say return false, meaning don't get stopped. So now we can copy this, or move it at least here. Let's just give it a bit more space here. There we go. So the first thing we want is we're going to detach this, and we're going to promote it to our distance again. So we can do that because it's only called once. So copy this. And once again, same thing as above. If this distance here is superior to 0, then that means that we do our normal check. If not, then we have to say that it is safe to keep going. So for the other one, once again, we'll copy this because we need this stopped as well. And we'll look if our L distance is superior. Is inferior, sorry, not superior. Close that, I don't need that to be so large. Go, so line these up, and once again, another return value, or return node, sorry. And plug this into it. There we go. Compile and save. And that will do it for our condition to stop. Next up, we're going to make a very small change to the bind events. It's just in case we ever have an issue here, we're going to do is valid, just to make sure we don't get any errors here. So plug that in and plug that in there. So on false, on invalid, we do nothing. We just leave it as is. And one last thing for the item is we need to make a few changes in the event graph. So the first one we want to change is for stop movement and also for force stop, if I remember correctly. No, specifically for force stop. We want to add a branch, and the branch is simply going to check whether we are already moving, because if we're not moving, then there's no point in stopping it. So we're going to get our movement, and we're going to check is playing. So if it is playing, then we want to stop it. If it's not playing, if it's already on pause, there's no point of calling all this logic because it's already happened. We're then going to copy this and use it also for the restart movement. So attach it here, but this time we want to say on false instead of on true. So let's move this up, align it, and that'll do it here. The last thing we need to change is our end of conveyor, because currently it will be kind of a bit of a waste of our C stop here, C force stop, because if we hit next conveyor, so another conveyor after, we're still telling it to stop and start again. So there's no real point in doing that. We're just going to remove that, and we'll add it here and here instead. So to do that, we'll call here CE force stop. And if we fail to input, then we'll also have to force stop. So let's save that. So that does it for the actual item. Next, we're going to move on to modifying the conveyor belt. So let's go and open that up. So our builds conveyor. Now, the first thing we need to do is we need to actually call our build override. So we're going to, sorry, not our build override, our destroy build override. So search for it in the overrides, call it here. And we want to detach the parent because we need to keep it because it's going to destroy the actual item itself. So what we need to do here is we need to tell it if it has items, we need to get rid of them, but also that we need to get rid of our attach points as well, because otherwise we might end up connecting to an attach point that doesn't attach to anything, which is a bad thing. We don't want that. So to do that, we'll start with the sequence. For the end of the sequence, we're going to get this start, and we'll get also this end. And with these two, we're simply going to say destroy actor. Both of them go here, move that a bit down. And after that, we can just call our destroy parent because that will destroy the actor itself. Next, what we want is we'll do our first input. We want to get items on conveyor, and we want to check is not empty, because if it is empty, we can just keep going. It's not a problem. We can ignore all this and just simply destroy the conveyor directly. If it does exist, what we want to do is we want to call, sorry, actually, we don't want a branch here. It's my bad. We want a while loop because we want to go through every single item and try to pick it up. And at the same time, we'll be telling it as we do it that way to remove and inform the ones in front and behind how to adjust. So what we want to do in this loop is we're going to need our player character, because when we destroy an item, we want to later maybe set up so that it goes into the player's inventory. So we'll cast to FPS, and we're going to say add, or more like pick up here, pick up item, and the item we'll be picking up is we're going to get item on conveyor, get copy, and we're going to place that here. We're then also going to need to tell it to pick up the item. So item picked up, and this is from our actual conveyor class. So this is what will readjust the information amongst the different items. So make sure that even if cast fails here, we still want to call item picked up. Let's move that there. So we're done with our destroy build now. Everything should function correctly. Now if we just try and... So now we have our items on it. If we go and destroy it, let's just wait. Everything's gone. The only thing that remains is the actual support, because the support isn't a part of our conveyor belt. So we can close that. It works correctly. Our destroy is working. Next, we want to make a minor change to our update location. Simply, we want to change this from add to add unique. That way we don't have 100 in the list very quickly because we've just moved around. So let's move that there. And the same thing here. So these are both, how to put it, once we have an attach point and we know we have an attach point, we tell it to ignore this build when trying to place. Otherwise it will count as an obstacle and we won't be able to actually place it. Same here, add unique, attach it here, and there we go. File and save. Next up is in our update spline visuals. So as you saw, when we try sometimes and connect here a different conveyor like this, we get this weird thing. So I don't exactly know why this happens, but I found a solution to it, but I'm not sure why this is needed. So the problem is this. For some reason, currently we have no collision, so it shouldn't be hitting anything. Yet, for some reason, no matter what I tried, we have no collision. We're not telling it to change its collision anyway here. But for some reason, this is still considered as blocking. So if we turn this to ignore, so make sure you check the top one. We just want to ignore absolutely everything while we're constructing. We can leave no collision. If we compile and save now, we won't have that issue anymore. Now, I really don't know why that is. As you can see now, it's really smooth. We don't have that weird glitch. There's no problem whatsoever. So let's close that. And that'll do it there. Next up in the list is we need to modify our add item to spline. So in items added to conveyor, sorry, not to spline, open that up and we're going to make quite a few changes here. We'll start off with a sequence here. And we're going to plug the first one into our update. And we don't have to change anything here at all. Leave it as it is. But we're going to need two new things. And this is what's going to actually inform the items that it's moved to a new conveyor and that an item might still be in front of it. So to do that, what we'll do is we need a new variable. And that new variable is going to be in the items. And we can just go ahead and duplicate our last item in queue. But we're going to call this last item on conveyor. And so what this will do is every time an item moves into a conveyor, it will change it because we added to the conveyor. And it will be saved as is And with that, we can then inform any new item that comes onto it, especially if it has no item in front. That, careful, this is an item in front that it can potentially run into. And because we update it like that, obviously whenever we change the item in front, it will change the information behind. So we want to get our new item here. And with new item, we're going to get item in front. And specifically, we want to get converted to valid, because this is going to check if we have an item in front. And the only case where we don't have an item in front is if we're talking about the first item ever spawned. And so that's the whole point. We want to make sure that if we do this here on not valid, we add a branch. Okay, so we want to make sure that the last item and, sorry, no. We want to make sure that new item and the last item are not the same. Otherwise, we're performing the actions for no reason. So just add a branch there and connect it. And on true, what we want to do is we'll get our last item on conveyor. We'll get our new item. And with new item, we will tell it to set item in front to our last item on conveyor. Put it on true. And we're also going to call our bind events, sorry, like this, bind events. And once again, binding will always be based on the item in front. So we can take our last item in queue, last item on conveyor, sorry, not in queue. Make sure you use the same one. We'll just move that here. There we go, compile and save. Next up, we need to modify our get next build and get previous build, because we need to, I actually noticed that we added the attach point here, but the attach point is only ever used in the items, and the items actually need the other one, not this local attach point. So we're going to simply go and change that in both of them, replace this end AP by other end AP, same for here, other end. And this is in the get next build, by the way, just so we're aware. We want to check if other end AP, just for these two, just for the outputs. We're not talking about this one here. We're talking specifically about the outputs. And for this, it's going to be replaced by this other start AP. Same here, other start. I'll just show you what it looks like. Remember, this is in the start one, in the next, sorry. In the get next build, this should be what it looks like at the end. Just show all. So then we can do the previous, which is going to be the same idea. In the previous one, we're just going to replace also with this, or other end, sorry. We'll replace this with other. Again here, so other end. And this one, other start. Go. So that's all of them reconnected. It should all work. Now with that, we should have finished our bug fixing. So let's give it a go. If we currently go and move this out and just rotate it here. So we bring it all the way here. What we'll do is we're going to actually, no, I'll make it a bit longer. Make a short turn here, and we will delete this and connect these two. So what this will do normally now is once it reaches the next part, so I need to actually look into fixing that, because that is a bit annoying visually. So as you can see, it all works no problem. But now what we need to check is if we cut off somewhere in the middle here, this all stops. But we need to check that the end here stops once it reaches that end there. Otherwise, this would be bugging. And there seems to be an issue, it is not stopping. So let's try and figure that out. Okay, so the solution to the problem that we just saw was that I forgot to actually set our last item in queue. Or last item on conveyor, sorry. They're very similar names, I should have probably named them something else. So just add it to the last then, it was already set up for it, I just completely forgot it, and then we won't have the issue anymore. Next up is the actual update, or more like we're going to be adding the smelter / constructor / buildings that can craft items, let's say. So to do that, we want to start off by making a recipe, let's say, a recipe for what we want to build. So given that we started with our items and we have only iron ingot and iron ore, what we'll do is we'll make a recipe for, let's say, smelting iron ore into iron ingots. So to do that, we want to use data assets again. So we're going to make a new folder called crafting. And in crafting, we will start with a blueprint, and we're going to look once again for primary data asset. Select it, and we'll call it DA underscore recipe. So for the recipe, go and open it up. You don't need these two anymore. What we need is we need a name. So a name of type text like the other one. We're going to need a duration this time because we need to know how long the crafting actually takes. Then we need the inputs and the outputs. So for the inputs and the outputs, we're going to take a type of structure inventory that we made. So this will store our quantity and which item it is. So we want an array for this because sometimes we'll have multiple items and we need to know that, so we have an array of them. Same for outputs. And with that, we are done for our recipe. Let's make our first recipe, and to do that, inside of crafting, we're going to right click, look for data asset, and sorry, didn't only search for that. Data asset, select it, and we're looking for our DA recipe. Select that, and we'll call it DA iron smelting. File and save, and we can open that up, and we'll call it exactly the name, iron smelting. We'll make it take 2 seconds to craft, as currently the items move along the conveyor belts 1 at a second, so we can test that it isn't just spawning new things on the output once it comes in. We make it wait 2 seconds, that we have it actually spread out. So for the inputs, we want, we'll say 1 item of iron ore, and the output will be, well, 1 iron ingot. So 1 in quantity and an iron ingot. So let's compile and save, and that does it for our crafting. That's all we have to do for the recipes, and obviously you can make as many of these as you want. We can also change the quantity, etc. Next up is actually making the logic that goes for it. So to do that, what we want to do is on our buildings base, we're going to create a new child, which is going to be called buildings smelter. And so for a building smelter, what we'll do, once it opens, there we go, we're going to copy the asset, at least from the viewport. We're going to copy it. So just copy this, Control C and Control V, and it will all appear in the same spot. It's just that we don't have to go through replacing our attach points and the rest, because either way there'll be inputs, outputs, no problem there. So for the smelter, we're actually going to be modifying our parent again and the actual container, because we need to make, I felt like there was a better way to do it. So we're going to be changing that. It will be a lot easier to use and modify later, because most of the logic will be inside the actual parent blueprint, and the rest will be very mediocre, very small changes, let's say. So the only thing we want to do here is we're going to select our static mesh, and we're going to change the material. We'll change it to, let's say, material widget material X. Maybe that's a bit bright. Maybe we'll put something else. So we can put, let's say, see how this looks. Buttocks color blend. So it's not too bad. It's just that we can tell the difference between this and a container, so we don't get it mixed up. That's okay. It's a bit bright, but it's okay. So now let's just add that to the world. So we'll go and drag it in here. So this is the input, this is the output, and we can connect it in with no problem like this. Let's just turn our player. So currently, if we run this, right, it's going to take the items out in the output, and then it's going to destroy them. Currently, it's not doing anything. If we go into the output, nothing actually happens because it's not storing anything, it's not doing anything. And we have that problem because of the world partition system. So let's go and make that visible. I'm gonna go make a new level because this will get annoying the longer we do this. So new level, just basic. There we go, and we'll save it, and we'll call it inside of Satisfactory. And we'll just call it new map. There's no specific name we need to give it. And inside of it, we're going to add our container. We're going to add our smelter. Let's make sure they're more or less aligned. And then we're going to add our player start. There we go. So now if we play, both there and nothing disappears. Good. Next we get into our actual changes. So the majority of the changes, as I said, are going to be in the parent build because we're going to be modifying that quite a bit. So I'm going to go and open that on my other screen and we're going to go through the functions one by one. So let's start off with our, I think I just closed it, but our conveyor attached output. The first thing we want to actually change here is I noticed that, so I tested it on my own side. Outputs don't need to have the actual timer anymore. So we're going to change it just like for the inputs. We're going to make it st inventory. So save that, change variable, and we don't actually need this anymore. So we can close that and we just want to say start outputting. So put that here. There we go. So there's probably going to be a few more errors here and there that we'll just have to fix as we go along. Next, we want another variable before I forget. And that variable is going to be our new recipe. So crafting recipe. And we want to select DA recipe. And we want to turn this to a single variable. Make sure it's exposed because we are going to need to change it here. And we'll set it to smelting. And this has a bad blueprint because it has a reference to our actual old output system. So for now we'll detach it because we're going to be modifying this as well to accommodate it. So let me just detach that. So we have that thing here. Now for the case of the container, we want to make sure we leave it empty. Because if it's empty, we're going to just skip a lot of the logic. That way we don't have to do anything in the container, just a few minor tweaks. So back in our buildings, so we just finished our conveyor attached. Next we want to do start outputting. So before we left start outputting empty, now what we're going to do is we're going to make it so that start outputting just calls the actions, which is we have our outputs and our outputs now actually store information of quantity and which item it is. So we're just going to say if we call start outputting, it means to go through this array or this map and start removing those elements. So to do that, we want to get a reference to outputs. We want to get the keys so that we know which attach point we're talking about. And we're going to do a for each loop. For each loop will be attached. And what we're pretty much going to do is we're going to get our outputs again here and call find. And what this will do is it will get us the information that we need here. We're going to break it. And with this information, we'll simply see if you're superior to 0, meaning we have an item to actually output, then we can output. And that means we want to output this specific item. So we're going to call our output from attach point. So on true, we're going to call this attach point, so the one here, and we actually want to reroute this because we need it a bit further back as well. So let me just move that down and reroute here and into item data. Same thing, branch at the end here as we did in the other parts. Branch here. And what we want to do is we want to call our modify here, and we're actually going to change this. So we're going to turn it into a pure cast because it's much easier to use like that. After a bit of testing, it's much easier and it works better anyway. We want -1 because we're going to be reducing it, because either way, the reason why it's better is because after testing, either way we're copying from a map, so we can't actually do a pass by that pass by reference, sorry, so that doesn't work. So we're just going to do it the old-fashioned way. So we'll modify that function after as well. So if this is true, we want to get our reference to our output again, and we want to say add, which will allow us to take our new struct here and modify it with our key here. So there we go. So this will update our map every time we output a new item. Next up is can output item, which we're going to leave the same, just leave it as true. Next, output from attach point, which is the same, we'll leave exactly as it is if I remember correctly. We have nothing we need to change here. So we finished with the outputs. Next up, the inputs. So for the inputs, we want to leave conveyor attached input. It's fine, but we want to modify can input a bit, because can input works by, well, will be working soon by using the actual recipe. So first thing we want to check is if it is valid, and if it is not valid, that means that we're talking about a container or something that doesn't require a specific recipe. So we're going to use return node here, and we're going to return that it's true, that it can come in because we don't have a specific recipe to stop it. So we're going to delete this now that we have another return value. And what we're going to do is with inputs, we're going to get the key, get the values, sorry. So for this, we want a for each loop. And with the for each loop, what we want to check is first if the item data is valid. So we want to break here and check whether this is valid. So we can hide the unconnected, attach it to the execute, and we want to reroute here as well. So let's just reroute here, and we want to break it again once for the quantity here. I'm going to say if you're double equal to 0, then if you're double equal to 0, or, so we're going to need another one here, go, or your input, or you're equal to the input item. So what this will do is, if either the item itself is not, so what this will do is it's going to go through it, and if at any point the item is either empty, meaning that there's nothing waiting to go in, or if it's equal to the item that is currently being filled up, then we can keep going. And the reason we do it this way, and then obviously we're going to also have to check something, and I don't know if we have this function yet, is slot. Okay, so we don't have that, so we need to make a quick function here. We're going to add a reroute, and we'll add double equal, and what we're going to do is right here we're going to link this and convert it to a function, and this function is going to be called is slot incomplete. And what this will simply check is whether whether this slot is full or not. And the reason we're doing this separately is because if these conditions are not met, meaning that if both these two aren't met, then that means that we don't want to do anything for this specific slot, because we're looking at different inputs here. But if we can confirm these conditions, then we can say return. Now, if it is true, it's true. That means we can take an item because we have the space, and in addition, we are either a empty one or it's the same item. On the other hand, if it is full, meaning it's not incomplete, then it doesn't matter if it's the item. Well, in that case, it can only be this. Then it means the slot is full either way, so we don't want to add it, and we can stop looking for this specific item to in. Now, on the other hand, if this is not valid, what we want to check is that means that the current the current input doesn't have a data asset set up on it. So in that case, we want to check if in the recipe the item that we're trying to input is a part of that recipe, and if it is, we will be able to add it. If not, then we ignore this item again. So for that, we need a for each loop again, is not valid, and we're going to be looking at our crafting recipe, and we're going to be looking at the inputs. And if the inputs are correct, like this, what we want is very similar to before. We're going to copy this, attach it here, but this time, very simply, we'll hide again. If it is, we accept it. If not, we keep going. in the list, sorry. Let's just center that. And so if it's true, return true. If it's false, we ignore. But if we reach the end of the loop, that means that it's not something part of the recipe. That means we completely ignore it. So this, yeah, obviously we're going to get an error. Let's set this up now. The is slot incomplete. So is slot incomplete is pretty simple. We're going to break this, and we're going to get our max stack and check whether if we add one, if we were to add one, sorry. No, sorry, we don't need to check that. We simply want to check if our current quantity is inferior to our max stack. And if it is, well, that means we're okay. We can add a new item. Next, we need to move on to the input from attach point. So originally we just had this and we modified it inside of the actual child class, but this time we're going to do most of it in here. So we want to keep our return value, so we're going to need that. And the first thing we want to do is we want to get input item. We want to get its data asset. And we're going to call can input item. And also worth noting, after this, we won't need the attach point for can input item, because now can input item, if I'm correct, doesn't care about the attach point. So we can remove that. Now this might make some errors in the container, but we're going to change those in a bit anyway. So we just have this, we put a branch, and if it cannot input, then we return false immediately. That means it's not possible. Remove that now, we have one set up. Next, what we want to do is with our inputs, so get inputs, we're going to find the attach point. So get attach point. And what we want to look for after breaking this is first if it is valid. So let's go and remove that, and we want to check is valid. If it's valid, we can take this information and simply add a value to our to a local variable we're going to make for the new inventory. On the other hand, if we're not valid, we're going to use the input item to set up the data asset and in turn the inventory. So first we'll do the non-valid because it's easier to understand. We're going to get our new item. So let's get it here. We're going to get data assets. And with this data asset, we need to get this here because you need a reference, it's easier. And we're going to promote it to a variable. We'll call L new structure. Now we're going to grab it and we want to split this and only connect this. And we want to make sure that the value is 1 now because we're obviously adding one item at a time. So the value becomes 1. And above this, we want to do the same thing, but instead of using this, we're going to recombine. We're going to use our find node. And as I mentioned before, we changed our modify item specifically for this. We can just attach it here and there. Actually, we want to remove the pass by reference because we don't need that. And we want to increase it by 1 because there's one new item added. We can then reattach these with a reroute node because they need to go to the same thing. We're going to add a sequence. And what we want to do is we're going to get our new inputs and we're going to add them. But for the sake of this being a parent class, we're going to actually convert this into a function so that in the specifically in the container, we can tell it instead of attaching it to inputs, we want you to attach it to the storage unit directly. So we can skip an entire step of the process just by doing that with a blueprint, with a function instead. So here we want to get attach point. We want to get our new structure. And what we'll do here very simply is once we've aligned them, select the input, select the add, and we're going to say collapse to function. And we'll call this modify input map. And this is specifically used right here as a blueprint because we could just collapse these nodes and it would work as well. but we want to be able to override it later so that we can avoid some stuff. That's the whole point. Next, we want a branch, and this branch is going to have a function which we haven't made yet, so we'll call a reroute here, and we can collapse it to get it ready. Collapse the function, and this is going to be called can craft, which very simply will check whether we can craft our item. So if we can craft, we're going to need to make some custom events to call here. So we'll do that in a second. And after the sequence, we're going to get our input item. Sorry, get input item, which is our variable at the start. And we're going to call destroy actor and return true because we succeeded. This goes into the then. And next we'll just get a reference to this. So in the event graph, very quickly, let's just add our custom events that we need. So for the custom events, we need 3. First one is going to be called CE underscore, let's get a bit closer, start crafting. The second one, which you can copy, is going to be called CE underscore stop crafting. And we're going to have one more, which is going to be called CE, and this is resume crafting. And these are going to all go into a timeline that we'll make, and it's going to be called TL underscore crafting. We want to set this to 1 second, a track called alpha, which is going to go from 0 all the way to 1. And currently we're not using we won't use the alpha track in this part, but if we want to later add, let's say a a loading or a progress bar, while an item is being crafted, we'll use this. So we attach stop to stop, we attach resume to play, and we attach start to play from start. So we can align all of these up, not line them up like this, it'll be more readable. There we go. On the output, on the finished, we're going to make some functions, but they're not done yet. Let's first go and finish off our input, where can craft, we're going to call start crafting. So let's do our can craft now. Okay, so first we'll make a new category here for crafting. So put is slot incomplete in it. We can put modify input, and we can put can craft in there. Modify item is kind of somewhat of an assist, let's say. It assists the rest. It doesn't really have a specific category that would be in. So now with can craft, let's get that underway. So first, if crafting recipe is not valid, so that's the first thing we want to check. Let me just move it all to the start here. There we go. If it's not valid, then we want to return false. But at the same time, we also have another check we want to do that will return the same thing. So we're just going to add a reroute here, and we'll drag this along here. So the check we want to do here is simply whether our crafting timeline exists, and we're going to call is playing. If it's playing, that means we're already crafting, so we do not want to do anything. So if it is not playing, on the other hand, we want to do the other checks. So here, if it is crafting already, don't want to do anything. If we're not attempting to craft, we don't want to craft either. So next we want to get our inputs. We want to get the values, because the values will give us the information of the amount of items we have. We're going to promote this to a variable we'll call L available resources. So attach it here, and we're going to use a sequence node here. And the first thing for the sequence node we'll do is we'll get our new crafting, or our crafting recipe here. We'll call inputs, and we'll put that into a for each loop. So attach it here. There we go. And what we're looking to find is we will break this. Okay, so once we've broken this, we want to promote this to a variable, which will be called quantity available. And, quantity required, not available. And then we want another one of the data type, which will be a reroute here and promote it to item required. Attach it here. And next we want another boolean, or a boolean, sorry, we'll call L found item. And what this is for is just to inform it while we go through our loop that we have found it. So we set it by default false here. And here we're going to add a for each loop with a break. That way we don't have to keep looking through if we have something already there. And what we want to do is we will break this. And we will check whether this is inferior or equal. And we want to attach it to the bottom part actually, not the top. And we want to get our quantity required. And if our quantity required is inferior or equal to our actual quantity available, then we want to check if this is also obviously the same item that we require, the item that we require. So we'll add it here, add, put a branch. And if these two conditions are met, then that means that we can consider that we found the item. Now, if we found the item, we can reroute here. Sorry, no, first we want to say that we found the item, obviously. And we're going to reroute this here. And pretty much what we're going to do is one by one, we're going to go through this array. And if ever we find the item, we tell it we found the item. If not, that means we can't craft what we want to craft because we're missing a piece. So to check that, because when we call break here, we still go to the completed, we need to check whether we found the item. Otherwise, this wouldn't be necessary if break didn't do this, but it does, so we have to do it this way. So if we didn't find it, then we return false, because that means that we're missing an item. If we're missing an item, we cannot craft. Now, on the other hand, on our second part of our sequence here, we want to check if there is enough space to output the item, because even if we want to craft, we can't craft it if there's nowhere for it to go. So we need to check that as well. So we want to get our outputs here. We will get the values as well. Attach it here. Remove that extra return values not necessary. We can promote our available resources here to the same, or we can promote this to the available resources even if it's not the correct word for it. It'll work, it's fine. We want a crafting recipe and we want outputs, and we'll do the same, pretty much the same check as before. Put a branch there, put a for each loop, sorry. Now this time if we return it is true, if we reach the end that means we have enough space. We want to break this again as we do most of the time. We'll save these as their variables again. Go apply this, reroute node. We want to get available resources. Let's just move that down. I didn't think we were that close. Get available resources, do a for each loop again. This time we don't need to break. And let's attach it there. This time we'll break it here as well. And instead of what we did before here, we want to check whether if we add this to quantity required, if it is superior to our actual max, because if it is, then that's a problem. But first we need to check whether it is the same item. So we get item required here. And if it is not the item required, meaning we're trying to output something that isn't correct, which shouldn't happen, just to make sure, we want to tell it that it can't. So the scenario where this would happen is if you were to craft, let's say, one item of type A, and you change the recipe later to craft item B, well, it won't be allowed to craft until item A is being completely emptied out. So that can be by the player picking it up, or by it being evacuated with enough time with the conveyor belts. So one more check right here. We want to check whether this is superior to our max stack here. go. So if the new quantity plus is superior, then we want to return false. So we'll return here false because there's not enough space. So with that, our can craft is done. So the next function we need is going to be a function that we're going to be using here. And what this function will be doing is it's going to send the crafted item to the outputs. So we're going to call it send crafted to output. So let's go and add that to the crafting. What we want to do is with our outputs again, we're going to get our keys this time, put it here, have a for each loop. And once again, we're going to need our crafting recipe, our outputs, because we need to know what we're adding to it. Another for each loop. And what we'll be adding is we'll be telling it, well, hey, in the outputs, we want to add these items, what we have in here. So we'll break this and we'll simply be telling it this is the quantity to add. So L quantity to add. So before we promote this, we want to check if this is double equal to our current one, because otherwise we don't want to add anything at all. And in that case, what we'll do is we're going to get our outputs here. We're going to find our attach point that we're referencing in this loop currently. Move this here, actually move that a bit closer, more space. We'll break this, we'll get our item data, plug it in here. We can just hide disconnected. And what we want to do very simply is on return here, we're going to say add to modify our map. And the map will be or the attach point we'll be modifying is this one, the end of the array. And the modification we'll have here is we'll use our find, and we're going to say modify quantity, attach it here. And the quantity is going to be our local variable. So we want to call consume item input items. So this will just pretty much destroy the items from the input to the crafter. So it'll be kind of a middle ground. It will still be called at the end here. Consume items. So what we want is we need our inputs. So get our inputs. We want to use keys. Plug it in here. We want a for each loop as usual. We want our inputs again here because we need to find the actual input we're talking about. And with that, we're going to promote this to a local variable. We'll be calling L input item. And we also want to call this here to get L attach parent, attach point. So connect these up, connect them up, there we go. And we're going to need another for each loop with a break here. Sorry, not for each, a for each loop with break. And we're going to be using our recipe with our inputs this time. Don't need that. Attach it here. And what we want to check here, well, we don't want to check anything. We want to actually just make a change here. We want to first know whether we're talking about the same input item here. So we want to get our input item, but we need to just be talking about our item data. So connect that like this. You can line these up and have a branch. Sorry, a branch. For some reason it didn't want to connect. There we go. What is going on here? There we go. So what we want to do is, if it's the same item, we want to modify the quantity. So we want to take this right here. And the reason we can do this without a check that we can, or that we have the space, is because we know that we allowed the crafting to start. So that means there's enough in the output. So this isn't great for long term because we might be able to change it later when we, how to put it, when the player can interact with a widget or something. But for now, we'll leave it at this. So we want to get our local input, and we want to say modify our item, which we'll get here. And we're going to add this to our inputs. So add to our inputs, and we have our attach point reference here as well. Attach this to true. And if that happens, then we want to actually just cancel the entire thing. So here we'll call our break. So just add a few reroute nodes just so it's more readable here. And save. And that does it for all the functions. We just need to add them right here. Actually, no, we need one more function, but we can add that once we're done with this. So first, we want to consume the input items. Then we want to send crafted to output. So first we remove the items, then we give them. Then we start outputting because now we have a new item available, or there were some in the past. We add a branch, and the branch is going to say can craft. If we can craft more, then we will. So we'll say CE start crafting. Last thing we need is an actual function for the start, let's say. And so that function is very simple. We need a crafting recipe here. We're going to convert it. And we're going to say, well, if we have a crafting recipe, we want to call a function called change crafting recipe. And what this is for, although currently it doesn't serve any purpose because we can't change it, we'll also use it to start up this. So we'll say change crafting recipe here. And the reason we call this only on valid is because we don't want to call this if we're in, for instance, the container, because it serves no purpose in there to call this. So we'll open that up and we'll get started. So first thing we want is we want to check if this is valid, because if it is valid, we want to update our crafting recipe to the new one. If it isn't valid, then we simply want to use our current one available. So we'll just reroute these a bit everywhere. Sorry. What we want to do here is we want to set our timeline length. So set play rate. And so this is why we have a duration of our crafting. We're going to use it here. So if this has happened, we've already set a value, and we've already checked before this can only be called if this is valid. So here we want to get duration, not duration, and we will be dividing it. But we'll be dividing 1 by it because we want to inverse the value so that it slows down when the length gets longer, when the duration increases. Then we want to set up our outputs, if I'm correct. Yes, the outputs. So grab our outputs, get our keys. And what we want to do is pretty much we want to tell our attach points what type they should be. So for that, with our for each loop here, we're going to tell it with our outputs add, and the add will take in obviously our array element here. And the actual value we'll get here is based on our array index reroute. We're going to get our crafting recipe here. Sorry, not both of them, just the crafting recipe. We want to get our outputs. Sorry, not outer, get outputs. Get an element. So you want to get a copy. We're going to get the array index, and this is going to get plugged into our add. And with that, we're done with all the functions setting up in here. Currently, if we create the child for the crafter, it will work. But currently, right now, the container is completely bugged and it won't work at all. So we need to make some changes there before we do some testing. Because in the case of the smelter, we've already made it and we don't need to touch it anymore. It'll work perfectly as it is right now. So now we want to open the container. And the values we need to change in the container, so is the start outputting, can output item, and we want to also modify the can input item as well. So that here. And the final one is modify the input map. So this is where we're going to be able to skip this kind of operation. So it's in crafting, let's open that. So we'll start by modifying what we already have. So in start outputting. So in start outputting, what we need to do is instead of going through outputs, we're going to go through our storage and move the items from storage to the output. Because our output already does the logic of taking the items from the output and outputting them, we just need to tell it where those are. So for that, we'll start, pretty strangely, with outputs. We're going to go through all of the keys, and we're going to say for each of these keys, pretty much for each output we have, we're going to get a value from the lowest position in our storage and tell it to, well, take that information and put it into our outputs. So at the end of this loop, we're going to call the parent one, which will actually output the items from here. So we want to get our keys. And with the keys, we're going to get the first index. So get a copy of 0. And with this copy of 0, we're going to get our storage again. We're going to find, we're going to use the value we obtained here. We're then going to modify our quantity by -1 because we lose 1. And what we want to do is storage here, we want to add, because we're going to modify it here to this new value. And this is the index we're modifying from. But we also need this for a few other things. So we're going to add a reroute, and we'll add one here to make it tidy. We also want a reference to our attach point, so we'll add a reroute here as well. So let's get this. And so with all this information, we want to reroute this as well, and we want to get a break, not a reroute. We want the item data because we need to tell it, just in case, which item data it is, because it tends to sometimes not be set correctly when we have our, our outputs and we add the value. So here we're going to say add the map. We're going to attach it at the end here. And what we're adding here is our item data. But we're also going to add the new value that we have here. So from here, we want to find with our value here, so with our attach points, and we're going to modify our item quantity. Now, because we only need so 1 here, by the way, we increased by 1 because we decreased by 1 in the storage. We just want to get the quantity, so we break the struct. And to finish off, we need to check whether this here, when we break it, we need to check whether the quantity is equal to 0, because if it is, we need to get rid of it. So if you're inferior to 0, because we do a subtraction, so we'll be at -1 when we fire out the last one. We want to get a reference to our value here, so the find, and we want to reroute here again, and we'll get storage, and we will say remove. So this will get rid of the actual function, or the actual item in the storage. Pause and save. Next, we can move to can output item. So let me do that. So sorry, actually can output item is fine. It works just the same. We don't need to change anything here. For can input item, because it's a bit different from what the parent does, so we can destroy that. We want to get storage. We want to get the length. We want to check whether it is inferior to the, well, actually, we don't have anything here. We're going to promote to a variable, which what we'll call max inventory size. And max inventory size is just pretty much how many slots we have in the inventory. We'll set it to something like 64 by default. That way we have a lot of space, don't have to worry about it for now. Attach it, and that does it. Next is the modify input map, which is just the thing that allows us to skip most of the logic. So instead of what we would normally have here, where we add it to our outputs, or our inputs, sorry, we're going to get our storage, and we're going to say get keys. And what we'll do is we'll be adding it. So we'll do a for each loop with the keys here. And what we're going to look for is whether the item already exists. So with storage, we're going to say find. We want to get array element. We want to check if slot is incomplete, but we also want to check whether the data is the same as what is coming in. So get, I think it is value. Sorry, yeah, we want to get value here, which is the input, and we're going to break it. And we're going to check whether these two are equal. So we can just remove the quantity here. And if these two are equal, that means that we can look to add them. And we'll check whether there's enough space to add them with this. And if there is, well, we need to modify our storage. Otherwise, here we return the node here, and we'll actually just make a new slot. So let's just do the new slot quickly. Get length here, get storage, and we'll say add the length. There we go. And the value we'll be adding is very simply, we're going to take value. We're going to make a structure, and the structure will simply be 1, because we always add one item at a time. So it works like this. On the other hand, once we reach the end here, a reroute of the array element, sorry. So the key. Want to reroute it all the way here, because we're going to be adding to our storage as usual. And what we'll be adding here on true, and we'll also add a return node here. On true, add this specific key. We want to be adding this modify item quantity, and we'll be modifying it by 1 because it's always one extra item. We can compile and save, and that should do it for all of the logic here, and everything should be working correctly. So let's give it a go and see what happens. Let's play. Let's start by checking if we open our... So that's not right. It is not doing anything. So this is our container, right? So we should have items popping out, but for some reason it is not. Let's have a look. Oh, okay, sorry. So I just noticed I completely forgot this. We need to tell it which we're modifying. Inside of the start outputting of the container, I forgot to actually attach the attach point here. So from this same node here to the actual one we're trying to modify. So it didn't know to update it. So now it should not work. Okay, so I just actually forgot something on my end again. For the input here, we need to make a slight modification. For the begin play in A buildings, the parent, we want to get direction here from attach point, and we want to do a switch. And with the switch, we're going to be setting up our actual outputs and inputs. So we want to reroute from here. Reroute here, we'll add another one here. And what we'll do is if it's an input, then we're going to get our inputs here, and we're going to say add. And we're going to leave them empty because we don't know what they are yet, and that's not important. So we're going to copy this and replace you with outputs as well. On output, we'll do the same thing. Same point here. Compile and save. Let's hope this works this time. And our items are outputting correctly. Seems to be working just fine. So they still stop, correct. Let's try outputting them into here. So they're connected. And we'll make something out here so that we can see if it is. So we have an issue. Shouldn't be outputting. There shouldn't be anything in there yet. So currently it takes about 2 seconds to craft a new item. So it is working. The crafting is working correctly. I just think there's a mistake in the fact that one of them spawned ahead of time. So let's try and figure out why that is. They keep spawning. Also, we have some iron here. It gets stopped. It doesn't go in because it cannot, because it's not part of the actual items. So let's try and figure out why this spawned one, even though we can't because there's nothing left. Let's have a look. So I made a bit of a mistake. Inside of change crafting recipe here, this isn't correct. What we need here is actually to break this, and we need to split our answer here. And we just want to attach the item data. The reason for that is because by default, we have 0 items in the output. We just want to know what type of item it is. So we leave item quantity 0, and now if we go and attach this at the end and pull it out, nothing comes out. But if we start feeding it the resources that it needs, it should work as intended. So let's have a look. Let's move it back. They go in, and once it has enough, it spawns one. About 2 seconds later, it spawns another, and so on and so forth. They all stop. And it will keep spawning until it can't anymore. Then it will wait inside and start slowly filling up. And obviously, currently right now it is still crafting because it has storage inside on the output, but it doesn't let anything else in because it's not the right type. So with that, this video is over. I hope you enjoyed. I'm not sure what you would like to see for the next part, because with this, it's kind of the basis of everything in Satisfactory. You could do anything with just this, with a bit of tweaking obviously here and there. What would you like to see next? What would you like me to do for Satisfactory? Or is there anything else, any other games or things you would like to see me try and make a video/tutorial on? Thank you for watching. I hope you enjoyed, and I will see you in the next video. Goodbye.